Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. The Quiet Giant: How Stanford Weinberg Revolutionized Physics and Changed the Way We Think. You've probably heard of Newton, Einstein, and even Hawking, but do you know the name Stanford Weinberg? He was a physicist who changed the way we understand the universe. Weinberg didn't just study forces, he revolutionized the way we think about them. In the 1960s, there were two forces that seemed completely unrelated. One was the electromagnetic force. The other was the weak force. These forces were treated as completely separate. Each had its own set of rules. Each worked in its own way. Yet, Stanford Weinberg had a bold idea. He believed that these forces might actually be connected. It was a theory so big that it seemed almost impossible. But Weinberg dared to think differently. Imagine being in the 1960s. Physicists knew a lot about the forces of nature, but no one knew how the electromagnetic and weak forces were related. That's when Weinberg stepped in. He proposed that these forces weren't separate after all. They were two sides of the same coin. This wasn't just a small suggestion. It was a complete rethinking of the way scientists understood the world. It was a theory that would challenge everything they thought they knew about forces. Weinberg wasn't just a physicist. He was a visionary. His theory wasn't just an academic exercise. It was a glimpse into a whole new way of understanding the universe. Weinberg's idea was called the Electroweak theory. It proposed that the electromagnetic force and the weak force were really the same force. The theory was as revolutionary as it sounds. If it were true, it would change physics forever. But it wasn't just a wild idea. It was a theory backed by mathematics and data. Weinberg wasn't the only one working on this problem. Other scientists, like Sheldon Glashow and Abdus Salam, were also exploring similar ideas. Together, they formed the foundation of the Electroweak theory. They were searching for a way to unite the forces. They wanted a single theory that could explain everything. For years, the scientific community struggled with this idea. Electromagnetic force and weak force were treated as separate entities. But Weinberg and his collaborators were convinced there had to be a deeper connection. It wasn't just about finding a simple answer. It was about understanding the core of how forces work in nature. At the heart of the Electroweak theory was something incredibly complex. It was the idea that the forces could be unified mathematically. But there was a catch. No one knew what that mathematical framework would look like. It was a mystery that had baffled physicists for years. But Weinberg wasn't afraid to take the challenge head-on. It took years of hard work and dedication to get to this point. Weinberg wasn't just another physicist following the status quo. He was blazing a trail no one had ever walked before. Even though his ideas were bold, they were also logical. He used mathematics to show that these forces could be unified. This wasn't just guesswork. It was rigorous scientific theory. Weinberg's theory was incredibly complex, but at its core, it was simple. The electromagnetic force and the weak force are two aspects of the same fundamental force. That idea, simple as it may sound now, was mind-blowing in its implications. It was a radical shift in how we view the forces of nature. But Weinberg didn't stop there. He wasn't just trying to create a theory. He was trying to predict something new. He predicted the existence of new particles. These particles, the W and Z bosons, were crucial to the Electroweak theory. But there was a catch. No one had ever seen these particles before. Imagine the impact of this prediction. If Weinberg was right, scientists would soon discover these particles. It was a bold claim, but it was grounded in the laws of physics. And the scientific community watched closely. The theory was met with a lot of skepticism. After all, predicting new particles is a huge claim to make. But Weinberg didn't back down. He believed in his theory. He continued to refine it. The more he worked on it, the stronger his conviction became. And as it turns out, he was right. In 1983, scientists discovered the W and Z bosons. That moment was a turning point. Weinberg's theory was no longer just an idea. It was a proven scientific fact. The discovery of the W and Z bosons confirmed the electroweak theory. It was a huge win for Weinberg and his collaborators, but it was also a win for science. It showed that sometimes, even the most radical ideas can be correct. Weinberg's impact wasn't just about his theory. His work helped lay the foundation for the Standard Model of particle physics. The Standard Model is the framework that explains all known fundamental particles and their interactions. It's the theory that explains how the universe works at its most basic level. But how did this all start? Where did Stanford Weinberg come from? He was born in 1933 in Minnesota. His family was academic. His father, Abraham Weinberg, was a mathematician. His mother, Betty Green, had a deep love for culture and education. This academic environment shaped Weinberg's mind from an early age. Weinberg's childhood was different from most kids. While other children played outside or watched cartoons, he was already thinking about complex math and science. He wasn't content with basic knowledge. He wanted to understand the deeper truths of the universe. From an early age, he showed a keen interest in learning. His parents, recognizing his potential, nurtured his curiosity. Weinberg didn't just learn from books. He learned from conversation. His father, a professor of mathematics, would discuss complex ideas with him. This was no ordinary education. It was a deep intellectual immersion. Weinberg grew up in an environment where ideas were discussed freely. It wasn't just about getting the right answers. It was about exploring the questions. As a young man, Weinberg attended New York University. In 1954, he earned his bachelor's degree. But even then, he wasn't satisfied. He knew that if he wanted to make a real impact, he needed to go further. So, he moved to California. He enrolled at the University of California, Berkeley. Berkeley was home to the brightest minds in physics. At Berkeley, Weinberg's education took a new turn. He began exploring quantum field theory. This was a complex area of physics that was still in its infancy. But Weinberg wasn't intimidated. He dove into the subject, determined to understand it. It wasn't just about learning the material. It was about pushing the boundaries of knowledge. Weinberg's journey wasn't easy. He didn't become a superstar overnight, but through hard work and persistence, he found his way. He connected with others who shared his passion for physics. These collaborations would eventually lead him to his groundbreaking electroweak theory. But the path to that theory was full of challenges. In the early 1960s, Weinberg began to work on unifying the forces of nature. He wasn't just interested in theory. He wanted to find something that could explain the universe at its most fundamental level. His work led him to propose the electroweak theory. This theory showed that the electromagnetic force and the weak force were actually the same force. The theory was met with resistance. Many in the scientific community were skeptical, but Weinberg believed in his idea. He knew it made sense. And as time passed, his theory gained traction. When the W and Z bosons were discovered, it confirmed what Weinberg had predicted. His theory was no longer just an idea. It was a proven fact. Stanford Weinberg's legacy lives on today. His work laid the foundation for the Standard Model of particle physics. His theories changed the way we think about the universe. He showed us that sometimes, the biggest breakthroughs come from daring to ask the boldest questions. He didn't just accept the world as it was. He challenged it. And in doing so, he changed everything. His electroweak theory is still a cornerstone of modern physics. It has influenced how we think about everything from elementary particles to the structure of the universe. Weinberg's work wasn't just important. It was transformative. His discoveries will continue to shape the future of physics for generations to come. So the next time you think about the universe, remember Stanford Weinberg. His contributions didn't just push the boundaries of science. They shattered them. His legacy is one of daring, innovation, and discovery. Weinberg showed us that the universe is full of mysteries, and that sometimes, the most amazing answers come from asking the hardest questions. Imagine this, it's 1967, and physicists around the world are locked in heated debates. The question on everyone's mind, can electromagnetic force and the weak force be unified? And you won't believe this, but while Stanford Weinberg was sleeping, he figured out the answer. It might sound like something out of a sci-fi novel, but Weinberg was the one who made it happen. Back in 1967, physicists had a big challenge on their hands. Electromagnetic force and the weak force had always been thought of as two completely separate forces. Electromagnetic force, of course, we all know it. It governs the electricity we use every day. But the weak force? It's something you don't hear much about. It's lurking in the microscopic world of particle physics, controlling things like radioactive decay. Scientists had suspected these forces might be related somehow, but no one could figure out how to fit them into the same theoretical framework. That's where Weinberg stepped in. He boldly proposed that if they could figure out how these forces are linked, it could spark a revolution in physics. And, believe it or not, he was right. But don't get the wrong idea. Weinberg wasn't flying solo on this one. The Electroweak unification race wasn't just between him and his ideas. It was a three-man showdown. Weinberg, Sheldon Glashow, and Abdus Salam were all pursuing this theory separately. Though each of them took their own approach, they were all heading toward the same goal. Think of it like three people independently solving the same riddle without even talking to each other. It's wild, but these three almost missed the chance to combine their discoveries. Their research focused on different aspects of the theory. Weinberg went deep into mathematical models, Glashow dived into gauge symmetry, and Salam worked from a particle physics perspective, eventually developing a more complete framework. Even though they weren't collaborating directly, their results ended up being remarkably similar. It's like three people drawing the same picture from different places. They didn't even compare notes, yet they came up with the same thing. And guess what? In 1967, each of them independently stumbled upon the core idea of electroweak unification. When these ideas came together, they formed the foundation of the modern standard model of particle physics. To put it simply, the electroweak unification theory combined the electromagnetic force and the weak force into one mathematical framework. The theory suggested that, at high energy levels, these two forces are essentially the same force. They're not two separate beasts but different sides of the same coin. Thanks to the work of Weinberg, Glashow, and Salam, we finally cracked the code. Their breakthrough gave us a new lens to view how particles interact with each other. It's like taking two seemingly unrelated puzzle pieces and finally snapping them together to reveal the bigger picture. And that picture was the Standard Model of physics. The Standard Model explains not only the types of fundamental particles but also how these particles interact through the four fundamental forces. Weinberg's electroweak unification theory laid the groundwork for this model. By 1967, Weinberg had proposed his groundbreaking theory. It wasn't long before it gained experimental support. Fast forward to 1979, and Weinberg, Glashow, and Salam were awarded the Nobel Prize in Physics for their work. But here's the kicker: despite all three of them solving the puzzle, they nearly missed out on receiving the award together. At the time, they were all making similar breakthroughs, but their work was essentially parallel, without direct collaboration. In fact, Weinberg almost didn't win the Nobel, because his theory didn't match experimental data perfectly at first. But, as luck would have it, the experiments eventually proved Weinberg's predictions, and he was recognized with the Nobel Prize. Honestly, Weinberg, Glashow, and Salam really hit the jackpot. Their discoveries didn't just revolutionize particle physics, they gave us the key to understanding the very structure of the universe. Their work caused waves in the scientific community and had a far-reaching impact on technological advancements. From particle accelerators to quantum computers, the electroweak unification theory helped spark a tech revolution. Weinberg, Glashow, and Salam didn't just change theoretical physics, they gave us the tools to explore the mysteries of the cosmos. Their theory was confirmed in 1983, when the W and Z bosons were discovered, particles predicted by their work. These two particles are central to electroweak unification theory. So Weinberg's theory didn't just change our understanding of the universe, it led to experimental breakthroughs and spurred technological progress. This is the science legend filled with surprises, breakthroughs, and glory. Now, picture this: 1979, three physicists standing on the stage at the Nobel Prize ceremony. And Weinberg's expression? It might have been something like, "Really? Can you imagine?" A physicist, standing on stage with his Nobel Prize, holding the trophy but thinking, was there a mix-up here? That's the real story of Stanford Weinberg. In 1979, Weinberg, along with Sheldon Glashow and Abdus Salam, was awarded the Nobel Prize in Physics. The three of them were recognized for their contributions to Electroweak unification theory. Their joint work, which began back in 1967, predicted that electromagnetic and weak forces could be unified. They even predicted the existence of two new particles, the W and Z bosons. But here's the catch: these particles hadn't been discovered yet. So the scientific world had to wait, with bated breath, for 16 years. Finally, in 1983, the W and Z bosons were discovered in particle accelerators, confirming the theory. And when those discoveries were made, the entire physics community was practically buzzing with excitement. Imagine the moment when their predictions were confirmed. It almost changed the history of physics overnight. So why did Weinberg, Glashow, and Salam win the Nobel Prize? Not just because they proposed a groundbreaking theory, but because their predictions came true. The discovery of the W and Z bosons didn't just prove their electroweak theory, it ushered particle physics into a new era. Their work laid the foundation for the Standard Model, showing how particles interact via the four fundamental forces. This wasn't a small thing, it was a massive breakthrough that changed how we understand how the universe works. And as for Weinberg, his emotions at that moment were probably more complicated than anyone's. He probably stood there thinking, "I didn't expect this to be a real mix-up." That line, dripping with humility and a touch of surprise, was a reflection of the true Weinberg. After all, his research wasn't a smooth ride. Early on, his electroweak unification theory didn't receive widespread support. Many people saw it as a bold guess, one that might never be proven. But Weinberg's persistence paid off, and in the end, it proved his unique insights into physics. The Nobel Prize brought Weinberg immense honor, making him one of the leading figures in global physics. But despite all that recognition, Weinberg's humility remained intact. He didn't stop exploring his electroweak theory even after the Nobel. Instead, he kept pushing for more experimental validation. And more importantly, he used his Nobel Prize as fuel to continue his quest for knowledge, rather than seeing it as an endpoint. By the time he received the award, Weinberg and his colleagues had already taken the next big step, building the foundations for the Standard Model. Weinberg didn't stop there. He kept challenging the mysteries of physics in his own unique way. And not only did he push the frontiers of science, but he also mentored the next generation of physicists, passing the torch forward. So, despite standing on that Nobel stage, Weinberg's thoughts might have still been, "Really?" But no matter how you slice it, that "really" was the humble reflection of a physicist who had changed the world and earned eternal academic fame. Now picture this, a physicist, not only toppling the theory of weak interactions but also starting to philosophize about the origins of the universe. Stanford Weinberg truly was a mad scientist of sorts. He didn't just revolutionize particle physics. He expanded his thinking to the very boundaries of cosmology. In 1972, Weinberg proposed the concept of the cosmological constant, a key element of modern cosmology. But that was just the beginning. While physicists were buried in formulas and particle accelerators, Weinberg was thinking about a much deeper, philosophical question: what's the deeper meaning behind the universe? Weinberg wasn't just crunching numbers and equations. He was asking, what's the hidden philosophy behind these equations? What does it tell us about the universe? He was a philosophical intruder in the physics world. Weinberg's contributions to cosmology didn't stop with the cosmological constant. He also proposed the Big Bang cosmological model, which today is the cornerstone of how we understand the universe's origin. This wasn't just a theory he came up with. He used math and experimental data to build a coherent cosmological model. The Big Bang concept was a powerful blow to traditional cosmology. It helped us understand how the universe went from nothing to something and revealed the history of cosmic expansion. And the cosmological constant? It led us to re-examine the accelerating expansion of the universe. Weinberg's introduction of the cosmological constant in 1972 remains a major tool for modern cosmological research. Behind those dry formulas was Weinberg's profound contemplation of the universe. He wasn't just a scientist, he was a thinker. In his 1979 book The Rational Cosmos, Weinberg explored the intersection of science, philosophy, and religion. This wasn't just a physics paper. It was a deep reflection on the meaning of the universe and human existence. Imagine a physicist discussing gravity waves and suddenly asking, what's the deeper meaning behind these forces? Weinberg did that. He didn't limit himself to numbers and formulas. He considered the philosophical implications of science. He asked, does the universe have an inherent rationality? This was a scientific and philosophical merging of minds. Weinberg skillfully blended the cold precision of science with the depth of philosophy. He believed that science isn't just about revealing the face of the universe. It can also help us understand the meaning of existence and even resonate with religious and philosophical thought. Weinberg's work in cosmology showed us a deeper layer of scientific thinking. He didn't just lay the groundwork for modern cosmology, he pushed boundaries and offered us many important insights into the universe. But he didn't stop there. He kept pushing cosmology forward, all the while never forgetting to ponder the philosophical meaning behind his discoveries. What he did wasn't just about deriving equations. It was about challenging our fundamental understanding of the universe. See, Weinberg wasn't just a physicist. He was also a philosopher in his own right. In his eyes, the universe wasn't just a mathematical language, it contained profound meanings that couldn't be captured by numbers and formulas alone. This mad scientist showed us the seamless connection between science and philosophy. And his work forever changed how we understand the universe, life, and existence itself. Imagine this: when Stanford Weinberg took the stage at lectures around the world, he wasn't just teaching physics. He was teaching you how to think. Yep, that's how magnetic his presence was. Weinberg wasn't just a star in the world of physics, he was a natural-born educator. At places like Stanford and Harvard, he helped shape generations of physicists. Picture this: you're sitting in front of Weinberg. You're not only learning about complex particle physics, but you're also feeling the deep impact he's having on how you think. He had this unique ability to make even the most abstract theories compelling. It wasn't just about explaining formulas. It was like a clash of ideas, a spark of something bigger. In Weinberg's classroom, things weren't simple. Sure, he went over formulas, but he also taught how to break complex problems down into simple parts and find solutions. His teaching style? Incredibly thorough, but also packed with humor and insight. He could make the driest material come alive. Students didn't just walk away with knowledge, they walked away with a new perspective on life and how to think. And here's the kicker: that influence wasn't confined to physics. Weinberg's class didn't just teach how to solve problems. It taught how to think independently, how to ask the right questions, and how to dive into the unknown. Even the average student, the ones who didn't become physicists, left his lectures inspired. One of his favorite sayings was, "Science isn't just about finding the answer, it's about asking the right questions." That became a life motto for many of his students. On top of teaching, Weinberg made some serious contributions to society. He wasn't just involved in big physics projects. His words had a lasting impact on the academic world as well. Some of his famous quotes are still passed around by his colleagues and students, guiding them through their thinking. Take, for example, this one: "The true joy of science isn't in solving the problem, it's in discovering the problem." That wasn't just a summary of physics. It was a profound observation on life itself. Weinberg's influence stretched beyond just the academic world. His way of thinking seeped into society. As a thinker, his work impacted scientists, philosophers, and even ordinary people. The critical thinking, rigorous academic standards, and endless pursuit of knowledge he championed became guiding principles for many in their work and lives. Many young scholars learned from him how to connect complex physics theories with real-world problems. Weinberg didn't just teach them to solve physics puzzles, he taught them how to face challenges in life. So, what's Weinberg's legacy? It's not just the academic papers he left behind. His true legacy? It's the way of thinking he instilled in others. That clarity, logic, and precision when facing tough problems. Even though he's no longer with us, his name still leaves a deep imprint on everyone who learned from him. His ideas, his teachings, and his character continue to inspire scholars, students, and everyday people alike. Stanford Weinberg didn't just change the face of physics, he changed how we think about the world. Now, you might think Nobel Prize winners live in the spotlight, right? Think again. Stanford Weinberg was the epitome of what we'd call a quiet giant in academia. While he stood under the spotlight of honor, his personal life couldn't have been more different from his scientific achievements. Weinberg was the definition of modesty. He wasn't one to seek the limelight, even though he had plenty to boast about. One time, when he stood on stage to accept the Nobel Prize, he actually seemed calmer than most of the other winners. He might be the only person who didn't get all teary-eyed or overwhelmed at the Nobel Prize ceremony. There he was, holding the golden trophy, with a face as calm as if he were sipping tea like it was just another day, not the culmination of the world's top academic honor. And, humorously, he even joked, "I thought this was just a misunderstanding." For a Nobel laureate, that kind of humility was both refreshing and unexpected. Weinberg's personal life reflected that same simplicity. He married his college classmate, Marcia Barnes, and together they had 2 children. Despite his soaring career, he always found a way to balance family and work. When he wasn't immersed in physics, he loved spending quiet time with his family. To him, family was his peaceful refuge from the academic storm. Weinberg's daily life wasn't filled with parties or social events. He preferred to stay in his study, reading his favorite books on literature, history, and philosophy, lost in deep thought. Yes, he wasn't just a physicist, he was a lover of literature with a reflective mind. In fact, his interest in history and philosophy was almost as strong as his passion for physics. He once wrote, "I find history and philosophy more fascinating than many of the formulas in physics." This was the side of Weinberg that wasn't just about equations and theories. He would spend his personal time reading classic historical works and studying the theories of famous philosophers. There are even small anecdotes about his habits that paint a picture of his personality. He wasn't fond of bustling social scenes. Instead, he preferred a quiet dinner with close friends. He rarely attended academic conferences, gala dinners, opting to spend his evenings in his study. You can imagine his approach to life, totally free from celebrity airs, humble and full of substance. In fact, Weinberg's friends often joked that he was the kind of guy you'd never find at a social event. If you went to a party and saw someone in the corner sipping tea, pondering the philosophy of history, that would be Weinberg, they'd say. His modesty wasn't just visible in his social life, it showed in his daily decisions and lifestyle. He was never swayed by the glitz and glam of the outside world. He held on to an academic attitude that was all about focusing on research, without getting caught up in fame and fortune. To many, Weinberg was the quiet academic star whose character was just as admirable as his scientific accomplishments. He didn't chase honors. He had a pure heart dedicated to science and truth. Maybe it was this humility and focus that made his scientific achievements so lasting and impactful. Weinberg's approach to life mirrored his approach to science, profound, simple, and full of wisdom. Today's science still stands tall on the theories Weinberg laid down. But have you ever wondered how his influence will continue to echo into the future? Stanford Weinberg didn't just leave an indelible mark on physics, his academic contributions have become the cornerstone of today's particle physics and cosmology. From Electroweak unification theory to his proposal of the cosmological constant, from the Standard Model to Big Bang cosmology, Weinberg's influence spans the entire scientific field. Even today, in the fast-evolving world of science, his theories continue to play a critical role in cutting-edge research. When we talk about particle accelerators or the deepest questions in cosmology, almost every discussion still circles back to Weinberg. These theories not only provided a framework for understanding the universe but also laid a solid foundation for scientists to explore the mysteries ahead. The scientific groundwork he set still serves as the peak that today's scholars are climbing toward. Weinberg's influence is still propelling science forward, and that impact will continue to affect the next generation of scientists, philosophers, and even everyday people. Whether you're in a lab or gazing at the stars, Weinberg's legacy will always be with you, guiding you toward a greater understanding of the universe. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.